So this video is going to focus on the pH analysis for the hydroponics project. A lot of what I'm going to talk about here can be applied to the plant height analysis, but this video is just focused solely on the pH analysis. So I've got a build for the demo of the pH analysis, and a lot of you have already seen this, but there were a few classes I wasn't able to show this to, so a video is always good to have. So there's three things to keep in mind or to focus on for the person doing the vision system for the pH analysis and the plant height. The first thing with image analysis is lighting. The second thing is you want to be able to differentiate what you're looking at from the background. And then the third thing is just keeping your camera in a consistent location, and I'll show you all those three here in a second. So the first thing is the lighting. For mine is super simple, but kind of ideal, like over idealized. I've got LED strips along all the edges with the camera, so it's facing the pH strip. So I'll turn them on real fast. So the LED strips do turn on, and they flood the background, flood the pH strip with light, which I know it's hard to see in the video because the LED strips are flooding or blowing out the camera, but they do flood the pH strip with light. So wherever I go with this, the lighting is consistent. So the first thing was keeping your lighting consistent. So you can bring a light from home, bring a flashlight, bring a lamp, do something like that to keep your lighting consistent, or just train it where you're going to run it. But the main thing is keep in mind that if you train it and your lighting changes, it's probably going to mess up your code. So lighting is consistent. The second thing was the background. So I've got my background just a constant white color, so you can see really easily that it's easy to see where the pH strip is, and that makes it really easy for the code to find the pH strip because it just pretty much differentiates the white from the strip. So it just calls the white one color and the pH strip the other, and it finds the pH strip really easily. And you'll see that when I run through the code in a little bit. And the third thing was keeping the camera in a consistent location, because again, if you move your camera around while you're trying to run your code, that will also give you some trouble. So I've got my camera punched through the board here, and so it's not going to move. It's not going to go anywhere. So it's staying here, and it's staying there for good. So again, keeping your camera in a consistent location is going to help you out. And I know that you guys are supposed to use your laptops, your webcams, or laptops, your iPads, your phones, and keeping those in a fixed location might be hard, but you can do something like laser cut to a little mount or something where you can try and place the camera in the same place every time. Something like that. So if you just do something like that to try and keep the camera in almost the same place, it'll make life a lot easier for you. So again, the three things to try and keep consistent are your background behind your pH strip, try and keep it one color. The lighting, I'm not saying you need to go out and get LED strips like I did, but try and keep it consistent if possible. And then your camera location, try and keep that in the same place too. So I'm going to take this now and I'm going to run through the code so you guys can see how the code works and how it actually finds the pH strip and uses the if statements to see what pH this is. And I realized I wasn't showing it, what pH this is. So, like I said, I was going to run through the code real fast and let you guys see what the code was doing, how it was finding the pH strip, how it was making the bounding box, and how it was doing the if statement to actually determine the pH. Before I run through it, arbitrarily copying this code into your code is probably not going to work because my code is built for my demo. And like I said earlier, my demo is kind of idealized with the LED lights that I have on it. And so the lighting is a big deal. And so this code is built for that lighting situation. So again, if you just arbitrarily copy mine into yours, it's probably not going to work. But the point of this is to let me run through each section and let you see what the code's doing, and then you can use that to build your code. So let me get going. I'll clear everything out just to be safe. Section A is just calling the webcam list and then identifying the camera that you want to use. So I've got two cameras on my laptop, the one I've got plugged in, and then the one built into the laptop. I'm going to use the one that's built in, the USB camera. So I'll call cam equals webcam 1. Then I'll pause for 6 seconds to let the camera warm up. Moving to section B, just taking a picture with the camera. The camera takes a picture. You can easily see the pH strip and then the white background. Moving to section C, I'm just breaking that picture into the RGB channels, which will be used here in a second for the image analysis. Section D is just assigning those RGB channels to the red, green, and blue variable, and I just did that just to be a little cleaner with the code. So section E is actually moving into the image analysis. So I'm going to use the tool, the IM tool, which is this image tool in Matlab, to look at the RGB values to differentiate the background from the pH strip. So the white background, let me come down here real fast. The pixel info, you've got the XY location of your pixel and then the RGB values of your pixel down there in the bottom left corner. So as I move my mouse around, you can see the RGB values for the white kind of tend to stay above 200. If you go up into areas where there's shadows, the green value goes below 200, goes down to about 190. And so as long as those values are above 190, 200, that's the background for this picture, and then the pH strip, those values are lower than 190. But the main thing is with this section is picking out the background. And so all those RGB values tend to stay above 190, 200, and so that's what I'm going to use here in a second, and you'll see what I do. So here I call the background anything where those RGB values are greater than 180 or greater than or equal to 180. And I just did 180 to be a little conservative just in case there's a shadow somewhere that I didn't see. And so I'm calling the background anything where the RGB values are greater than or equal to 180. And then anything else that's less than 180, where the RGB values are all less than 180, or where it does not meet that requirement of them all being greater than or equal to 180, is not the background. And so this image is the background. So anything where it's white is the background, and anything where it's black is not the background. So anything where it's black is what we're kind of wanting to look at here. So moving to section F, I'm inverting that background image because I'm going to use a tool in a second called BW Area Open. And what BW Area Open is, or does, is it looks at white sections in a picture and removes sections of white based on a specified size of pixels or number of pixels. And I'll go through that in a second after I do this inversion. So just inverting the image. So now everything that's black is called the background, because everything that's black is the white background, and everything that's white is the image, and the image is not the background. And so you can see here that the pH strip is pretty easily identifiable, but we've got this white section down here around the servo that we want to get rid of, which we're going to use BW Area Open to do. So moving to section G, using BW Area Open. So like I said, BW Area Open removes sections of white from your image that are less than a specified number of pixels. And so we're going to use that to remove this white section here and leave just the pH strip. And so I've got 6,000 pixels here. So what BW Area Open is doing is it's going through and removing white sections that are less than 6,000 pixels. So let me run this section. And so now that I used BW Area Open, now it's only the pH strip that's left. And that's exactly what you want for your image. You just want to have everything else and then the pH strip alone. So that's exactly what you want to see for your image, or for your image analysis, for the pH analysis. So now moving on to actually getting the extents and the center of the bounding box. And the reason we're getting the center of the bounding box is because the center of the bounding box is where you need to take the pH analysis, or read the pH value, or somewhere in that bounding box. I just use the center. So let me run this. So there's a table called the bounding box table, where the first column is the x coordinate of the bounding box, the second column is the y coordinate, the third column is the width, the x width of the bounding box, and then the fourth column is the y height of the bounding box. So what I'm doing here, where I have box table, I'm just assigning that bounding box to the variable box table. and I'm using box table again equals box table to turn it into a readable table. And it is important to note that these are brackets right here, not parentheses. So again, if you try and make this code, make sure these are brackets and not parentheses. So moving on to the X position. So I'm making a variable that is the X position equals box table row 1 column 1. So it's just this value right here. So it's getting the X position of the table, or X position of the bounding box. The Y position is box table row 1 column 2. So row, and I should have said this earlier, these headings are not in the table. That's just us putting those there for reference sake. These values are the only things in the table. So row 1 column 1, row 1 column 2, row 1 column 3. So the Y position is box table row 1 column 2. So now it's this number, the Y coordinate. So now for me, like I said, I found the center of the bounding box, and I used that value as the place where I would take the pH reading later on in the code. So the center X is the center of the bounding box in the X coordinate. So I took X position, which is this variable, which is just the X position of the bounding box, and then I added the box table row 1 column 3, which is the width of the table divided by 2. So it's the width of the table divided by 2 plus the X position. So now it's essentially just the center of the table in the X direction. And I did that same thing for the center Y, where I took the Y position, added box table 1, 4, which is the height, divided by 2, so half the height plus the Y position. So now that gives me the center of the X and the center in the Y, and so those two values give me the center of the bounding box. Moving to section I, adding the bounding box. This code, I won't try and describe how it works, because it'll get too in-depth too quickly. But this code is what adds the bounding box to the image. For yours, you do not need to have this plot center, or this little bit of code right here, because this is what adds a plus to the picture, which, let me run that so you can actually see what I'm talking about. So this code adds the bounding box around the image, where the blue box is the bounding box. And this is what we want to see when you demonstrate your build to us at the end of the semester, this bounding box around your image. We don't want to see bounding boxes over here. We don't want to see bounding boxes over here. We just want to see the bounding box around your pH strip. This code, this little section, this little line of code here, adds this red plus, which that's just for visualization of where the pH is being taken from. So this red plus is the center of the bounding box, and in my case, I'm taking the pH there, but you do not need to have that plus there unless you want to put it there. So again, this code adds the bounding box around your pH, and this is what we want to see at the end of the semester, just the bounding box around your strip and not anywhere else. Moving on to section J, pulling the pixel value from the center of the bounding box. So what I have here is the pH X, pH Y. I'm rounding the center X, center Y values, these values right here, because they need to be at a whole number and not a decimal. They don't need like 20.2, it just needs to be 20. So that's all they're doing here, is just rounding the center X, center Y values to the nearest integer. The pH at point, strip pH Y, pH X, the X and Y's need to be switched because of the column and rows. It's the same thing as the Matlab assignment where you made the if statement to determine the pH based on the example pH values that we did for the pH analysis assignment. The pH at point looks at the red value, pH at point, green value, pH at point, blue value. And then it says X1 pH1, X1, X2 pH2, X3 pH3. So X1 equals the red value of the pH, X2 equals the blue value, or the green value of the pH, and then X3 equals the green value of the pH, the blue value, I'm sorry. Let me run through it again to make sure I say it right. X1 is the red value, X2 is the green value, X3 is the blue value, the RGB values. Finally, moving to if statements, I have an if statement that works for 0 to 14, which you all do not need to have it going from 0 to 14. I think it just needs to be 4 to 9 for this project. But again, I just did 0 to 4 or 0 to 14 just because. And so let me run the if statement, and then it shows that the pH is 6, which if you compare that to the little tube, the little chart on the tube, that is a pH of 6. So the code is working like it's supposed to. And real fast, these if statements were built from decision trees that were built using my build. So again, they were built, those decision trees and these if statements were built for my lighting and my build. And so again, these probably won't work for yours. So you'll have to build decision trees again or use your decision trees that were built for your build. So again, these if statements work for mine and they probably won't work for yours. So this was a run through of the code. Like I said, if you copy this directly into yours, it's probably not going to work. I mean, there are sections of this that you can take, but the whole code itself, like, you just can't arbitrarily copy the whole thing into yours and expect it to work. So this was meant more as a way of just letting you see what each section's doing and then letting you use that knowledge to build your own code. And as always, feel free to email me if you need if you have any questions about it, and I'll gladly help you out.